Hi, good evening, everyone. We'll go ahead and take some more stats questions today. I hope you have done the questions I had given you in the previous class. Go ahead, give this question a try. One of the reasons why sample median is used as an estimator of population mean is that. What is the advantage of sample median? Okay, very good. That is the right answer. There is no, no difficulty in answering this. So sample median is unaffected by extreme value. Median में कभी भी extreme values नहीं आती हैं. It is always the 50th, the number that is cutting the data in 50th part, 50% here and 50% here. So therefore, yes, the answer would be C. Go ahead, give this question a try. X is a random variable. X follows a uniform distribution between -1 and 1. You have to find covariance between X and X square. Give it a try. Okay, how about others? Okay. So there are two ways to think about this question, okay? The first way, okay. There are two ways to think about this question. The first way to think about this question is to go ahead and to use the formula, right? And the second way to think about this question is that whenever we talk about covariance, covariance is always accounting for your linear relationships. It does not account for non-linear relationship. That is another way to think about it. But if I actually use the formula also, then also I should be able to prove the same thing. मेरे को एक same answer आना चाहिए. So how do we find the covariance between two variables x and y? It is expected value of x, y minus expected value of x into expected value of y. ऐसे ही covariance निकलते हैं. So if I were to find the covariance between x and x square, it will be expected value of x into x square minus expected value of x into expected value of x square. This will be expected value of x cube minus expected value of x and into expected value of x square. Now, whenever you have uniform distribution, what is the formula of expected value? What's the formula of expected value? Usually also, how do we find expected value? The formula of expected value of any variable. अगर मुझे किसी भी variable का expected value निकालना है, it is x fx dx integrated, right? This is how you find expected value. So if I were to go ahead and if I were to find the expected value of x cube, it will be x into x cube, क्योंकि x cube का expected value निकालना है. So it will be x cube into its probability density function between -1 to 1. अगर x का एक्सपेक्टेड वैल्यू निकालना है, इट विल बी x इंटू PDF ऑफ दिस बिटवीन -1 to 1. अगर x स्क्वायर का एक्सपेक्टेड वैल्यू निकालना है, इट विल बी x स्क्वायर fx dx बिटवीन -1 to 1. दिस इज हाउ वी फाइंड एक्सपेक्टेड वैल्यू. जिस भी चीज का एक्सपेक्टेड वैल्यू निकालना है, इफ आई वांट टू फाइंड एक्सपेक्टेड वैल्यू ऑफ x क्यूब, it will be x cube into PDF. If I have to find expected value of x, x into PDF. If I have to find expected value of x square into PDF, right? And what is PDF? वो भी हमें पता है कि for uniform distribution, we know fx, how it can be written? 1 upon b minus a. So we know it can be written as 1 upon b is what here? b is 1 and a is -1. So कैसे लिख सकते हैं इसे? 1 upon 1 minus -1. That means fx is nothing but half. बस, just put it here. So what will you get? X cube into half का integration, x into half का integration, x square into half का integration, and solve this. That's it. So even if you don't know how to go ahead and how to solve, अगर ये hit नहीं हो रहा कि one of them is, I'm trying to find a non-linear relationship, and the non-linear relationship will give me covariance as 0. Suppose ये hit नहीं होता, then you can go ahead and you can use this formula also. Right? And covariance ka formula, you need to remember expected value of xy minus ex into ey. And expected value ka formula, you need to remember ki whatever expected value we go ahead and we find out, it is x fx dx integrated. And for uniform distribution, fx is nothing but 1 upon b minus a. So these are some things that you have to remember. But now you can go ahead and solve this. So if I go ahead and if I solve this, I will get x by 4, this between -1 to 1 minus x square by 2 between -1 to 1 into x cube by 3 between -1 to 1. So 1 minus -1, this will simply be 0, minus 1 minus 1, this will also be 0, answer will be 0. You'll get the answer as 0. That's the answer to this question. Okay. Okay. So please keep this formula in mind. Write this down somewhere. It is very useful formula. Keep this formula in mind. How to convert expected value in form of integration. Okay. Try and do this one. Give this question a try. Okay. Good. Very good. Yes. All of you are correct. That is the right answer to this question. So, देखो. See, Z of, when we find Z का value at 99% confidence interval, two tail में कर लेते हैं. So it is 2.58. And when we find Z at 95% confidence interval, again two tail में, it is 1.96. So if I were to find the confidence interval of, suppose confidence interval of mean, ठीक है? तो mean का confidence interval will be what? It will be sample mean minus plus standard error into the value of Z. Into the value of Z. So it means it will be mean, sample mean minus standard error plus standard error अगर 95% है तो it will be 1.96. And if it is 99%, it will be 2.58. Right. So you understand the difference. यहाँ पे I am adding 1.96 times this. यहाँ पे I am adding 2.58 times this. माने मैं ज्यादा नंबर ऐड कर रही हूँ. I am adding more. Similarly, here I am subtracting 1.96 times standard error. Here I am subtracting 2.58 times standard error. So I am also subtracting more. So it means that when we talk about this, अगर मैं इसके कंपैरिजन में इसको देखूं, we are subtracting more here and we are adding more here. It means that we are creating a wider interval. हम ज्यादा ऐड कर रहे हैं ये वाला साइड पे and हम ज्यादा subtract भी कर रहे हैं. So we are creating a wider interval. So you are correct. Yes, the 99% confidence level will be wider as compared to 95% confidence level. That is the correct answer. Okay, come to the next question. Try this one. Very easy. This is just the formula of chi-square. Okay. How about others? Let x1, x2 be random sample from normal distribution with parameter mu and sigma square. Then the random variable, you're given a random variable, has a chi-square distribution with n-1 degrees of freedom. We know this thing, right? Now it says here x bar denotes mean of this. Suppose area under chi-square with n-1 degree of freedom to the right. Area to the right. It is given as degree of freedom n-1. Okay. Now we want to create 100 1 minus alpha % confidence interval for the variance. So we want to create 100 1 minus alpha % confidence interval. अब एक बात बताओ, tell me something. Whenever we create confidence interval, one thing that we are sure is that, so this is, suppose this is a confidence interval. So this will be my upper limit. And this will be my lower limit. It means I need a smaller number here. And I need a larger number here. पहली बात तो ये. Secondly, of course, since the formula is n-1 s square, since the formula is n-1 s square, it means that I will have n-1 s square only. I cannot have n s square. So it means that automatically options C and D are eliminated. I cannot have n s square. ये तो नहीं हो सकता है C and D. The only two options that are left up to me are option number A and option number B. Now, I want a small, so जो पहला value होना चाहिए before comma, I need that to be a smaller value. The value will be a smaller value if the denominator will be larger. When will I get a smaller value? The more the denominator, जितना ज़्यादा denominator होगा, वो उस पूरी value को नीचे कर देगा. It will fall, make it come down. So basically, we want to go ahead and we want to compare the denominator. One is chi-square alpha by 2 n minus 1, and one is chi-square 1 minus alpha by 2 n minus 1. We want to compare the denominators. That is what I want to do. Now, suppose I take alpha. Suppose I take alpha to be 5%. So what will I go ahead and what will I get here? It means I am evaluating this. 5% means 0.05. So I am going ahead and making 95% confidence interval. I am finding 95% confidence interval. Here, if I take alpha to be 5, if I take alpha to be 5%, so this will be my chi-square value corresponding to 5%. And this will be my chi-square value corresponding to this. Isn't it? This will be my chi-square value corresponding to this. So which value do you think? Here, 2 is here, huh? Just here. Which value do you think is smaller or larger? Which value should be larger? What do you think? This value or this value? What happens to chi-square? Which value do you think would be a larger value? Quickly, can you go ahead? I don't have table here. I won't be able to print the table in my tab, right? Can you quickly open the chi-square table if anyone has access to it? Just quickly open the chi-square table. This is something you should be very clear with. Let me see if I can somehow share it on the screen. Open the chi-square table. Quickly open the chi-square table. Just Google it. Open chi-square table. And for chi-square table, just go ahead and find the value of these two. Take n to be any number. Suppose take n to be 10. So find out chi-square for 0.05 by 29 and find out chi-square for 1 minus 0.05 by 2 comma 9. That means find out chi-square for 0.025 comma 9 and chi-square for 0.975 comma 9. ये दोनों values मुझे देख के बताओ from the table. I won't be able to open Google here, but just go ahead and just find out these two values and try to tell me what values you are getting. You have to be very clear with this thing. Okay. $19.023 and 2.70. 2.70. Is this correct? These are the values you are getting. Now compare. Now tell me which is a greater value. This is a greater value. So if this is a greater value and I need greater value in the denominator ताकि वो value कम हो जाए, which one do you think should be the answer? A. This will be the answer to this question. This is how you can go ahead and interpret it. I want a greater denominator. Denominator जितना बड़ा होगा वो मेरा लोअर लिमिट बनेगा. Denominator छोटा होगा तो वैल्यू बड़ी होगी. That will be my upper limit. So now I want to see which value is coming out to be greater. When I find out this value, I just took some example. I am getting this. When I find out this value, I am getting this. It means, and this is very important, now you can just generalize it and you can keep it as a rule. This means that this is greater than this. तो जो भी ग्रेटर है वो हमें डिनोमिनेटर में ग्रेटर वैल्यू लेके आना है अपना लोअर लिमिट बनाने के लिए. सो विच मीन्स दैट दिस विल बी कमिंग इन द कॉन्फिडेंस इंटरवल लोअर लिमिट and this will be coming in the confidence interval upper limit. Okay, so the answer to this question should be A. Answer will be A. Is this clear now? Anyone who still has a doubt in this? Okay, let's move on to the next question. Do this question. These are all 1 mark questions. This should not take a lot of time. बहुत simple questions हैं ये. Suppose you have 500 observation, you regress wage on labor market. This is your OLS estimate. The estimated equation implies you have to tell the returns to experience. Returns to experience. So return to experience can be what? What will be return to experience? It means how your wage changes as experience changes. We can call this as the return you get from experience. So if I find out how my wage changes as experience changes, if I differentiate this, I will get 0.298 minus 0.0061 into 2 into experience. So my return from experience will become 0.298 minus 2 times 0.061 into experience. This is my return from experience. कि जब मैं अपने experience को change करती हूँ, when I change my experience, how my wage changes. That's the return. Now I have to check whether this return from experience, is it constant? Is it decreasing? Is it increasing? So I have to check how this return changes. क्योंकि इसका rate check करना है, right? We need to check the rate of return. It means I need to check how this return changes as experience changes. So I will differentiate return with respect to experience. So what will I get? 0 minus 2, 0.0061. So it will be minus 2 into 0.0061 and it is negative. It is less than 0. Negative means diminishing returns from experience. That's it. Diminishing returns from experience. Right? So that will be, so the returns to experience will be strictly diminishing. Answer will be B. इतना ही था इस क्वेश्चन में. They're asking to find out returns to experience. So first you find returns. Returns is how wage changes as experience changes. And then it is asking कि ये जो return निकाला है, how this is changing. इसका rate पूछ रहे हैं. So you differentiate it again. You can. That's correct. D option can also be checked. Experience has no statistical significance on wage. So you can create, definitely you can go ahead and you can create a null hypothesis that beta 1 equal to 0, alternative beta 1 not equal to 0, and you can find the Z value. You can do that. So it will be 0.298 divided by 0.041. Right? You can go ahead and check this value. If this value is coming out to be good enough, they have not told you what alpha is. So you can just take it to be more than 1.96. If it is coming more than that, then it is having a significant, effect. So if I just find out 0.298 divided by 0.041, it is coming out to be 7.26, which is very high Z value. So therefore, we can say that it has impact on wage. For D, you can check both, beta. Both will have. Actually, sirf experience ka pucha hai na, so this is enough to check because this just tells whether the rate of experience has an impact on wage or not. This is enough to check for experience having an impact on wage or not. Why not we use coefficient 0.0061 as beta? You can, but that will always tell you the rate of experience. Square hai na? This tells you the rate at which experience is changing. That's it. That is why. Okay, and nevertheless, even if you should be checking it, even if this becomes 0, imagine, suppose iska kuch bhi, it doesn't have any impact. Suppose you're not able to reject null. Then also you cannot falsify the statement. तभी भी experience का impact तो है ही ना wage पे. So it is only asking experience का impact on wage. It's not asking the rate at which experience impact wage is that significant or not. So checking this is enough. No, no, no. Only B is correct. D says experience has no significant impact. Z is coming out very high. So you are able to reject null in favor of alternative. So we are saying experience has significant impact. Isn't it? So D is incorrect. Okay. Go on to this one. This is a very good question. I want you to try this one. Very, very important. Null fx is equal to 2x. Alternative fx is 2 minus 2x. Alpha, type 1 error. Beta, type 2 error. Find test procedure of the form reject null if x is less than k. Alpha is given to you as 0.09. We need to find k and beta. We need to find k and beta, right? So first find out what is type 1 error. This is already given to you as 0.09. Okay, good. That's the right answer. Yes. Yes. Reject null if k is less than x is less than k. That's correct. So type 1 error will be what? Reject null given null is true. Reject null given null is true. When will we reject null? We will reject null if x is less than k. So we are rejecting null when x is less than k. X less than k means x will be between 0 to k because x is between 0 to 1. So x less than k means x will be between 0 to k. So since we are rejecting null, it means that x is between 0 to k. But null is true. So if null is true, we will be taking null hypothesis. Since null is true, so we will be taking null hypothesis. This will be type 1 error. And this is given to me as 0.09. So 2x square by 2 from 0 to k, 0.09. X square from 0 to k, 0.09. K square, 0.09. K under root of 0.09, 0.3. 0.3. So k will be 0.3. That means this is incorrect, this is incorrect. Now, go ahead and do type 2 error. Okay, good. Now do type 2 error. So probability of, see, you are saying rejecting null. Now it will be accepting null, right? You are saying null is true. Now it will be null is false, right? Null is false. So go ahead and give this one a try. Accepting null when it is false. Another way of writing this can be rejecting alternative when alternative is true. You can also write it like this. You are rejecting alternative when alternative is true. So when will you go ahead and when will you reject this when this is true? You can make condition based on that also. That is correct. Yes. So your region would be from now k to 1, right? And what would be your function now? Your function will be 2 minus 2x dx, right? And what is your k? You have already found out that your k is 0.3. Just solve this. So you will get 2x minus 2 x square by 2, 0.321, 2x minus x square, 0.321, Just put the values, huh? So when you will just solve this, you will get the answer as 0.49. That will be the answer to this question. Okay. Just remember the formula well. It's not a very difficult, type 1, type 2 error are not difficult, but they're most common questions that can be asked in exam. So you have to do them thoroughly. Now, another very common question in exam is this. Circular table. Try to do this question. Again, important. Try this one. So first of all, remember that in circular questions, whenever you have to find the denominator, that means whenever you have to find the total probability, you will always fix one person's position for reference. Circular question में हम जितने लोग होते हैं उसमें से एक का पोजीशन फिक्स करते हैं, सिर्फ तभी हम बाकियों को अरेंज कर सकते हैं. We can arrange the remaining person. So whenever we have to find the total probability, what are the total ways in which they can be arranged, right? So whenever we have to find the denominator, total ways in which it can be arranged, it will be always n minus 1 factorial. So there are 2 women and there are 4 men. So there are 6 people. So the total ways in which they can be arranged, one person is always fixed because it's circle. I don't know the start and end of a circle, right? So we fix the position of one person. So denominator will be 5 factorial. Itna yaad rakhna hai pehli cheez. The denominator will be 5 factorial. Now read the question. Now find out the numerator, favorable. 2 women and 4 men are to be seated randomly. Find the probability that women are not seated next to each other, right? Women are not seated next to each other. So it means that women have to always be in such a way that there is a men in between. So if I have, suppose I fix men here, men 1, there are 4 men, men 2, men 3, men 4. Then where all these 2 women can come? They can come here. They can come here. They can come here. And they can come here. Whenever they will be coming in this way, it means that they will never be coming together. Right? They will never be coming together. So first of all, let me just position the men first. Then we can talk about the women. As I told you, it's a circle. I am finding the favorable circumstances now. It's a circle. So in circle, we will fix the position of one man. Let this man be here. The remaining 3 men, they can be positioned in any way, right? The remaining 3 men can be positioned in any way. So since they can be positioned in any way, एक को तो fix करना जरूरी है, it is a circle. The remaining 3 men can be positioned in 3 factorial ways. Now, what are the possible places where a woman can come? Here, 1, 2, 3, and 4. If they come in these positions, this would mean that it is sure that they will never be sitting together. So there are 4 places to be filled up by 2 women. I need to arrange, arrangement hai. Okay? I need to arrange 2 women in 4 positions. So it means that out of 4 positions, I need to arrange permutation. I need to arrange them in 2 positions. Out of 4, 2. So now this is your favorable number of circumstances. Now find out the probability. So probability will be 3 factorial 4p2 upon 5 factorial. Just solve this. Right? So when I will be solving this, I will get 4 into 3 into 3 into 2. And then denominator will be this. 3 by 5 will be my answer. Not for circular arrangement, we always use permutation. For arrangement, we always use permutation. For selection, we use combination. If I have to arrange people, it will be permutation. If I have to select, suppose it would have said that 2 women and 4 men, we need to select and form a committee of 1 woman and 3 men. Whenever you have to select, it is combination. Whenever you have to arrange, it is permutation. Yes, you can also do 1 minus probability of sitting together. That's also correct. Definitely. Okay, try this one. This is easy. Give this a try. Just post that answer. Huh? I will check. Don't worry. Just do 1 minus probability of women sitting together. Post it in the group. Let me check it. Okay, just do this one. This is easy. It's like a 1-mark question. A fair coin is tossed until head comes up for the first time. Find the probability of happening odd numbered tosses. Yes, that is correct. So odd number of tosses means head पहले ही आ गया in the first position. या फिर or means and. You see a tail, then you see head. Or you see a tail, you see a tail, you see a tail, you see a tail, and then you see a head, and so on. This is head in odd positions. Now you need to go ahead and you need to find the probability. So how can you go ahead and find the probability? Probability of head is half. Probability of tail is half. Tail is half. Head is half. Tail is half. Tail is half. 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 Head is half. And so on. So what you would notice is that this is 1 by 2. 1 by 2 to the power 3. 1 by 2 to the power 5. And so on. And this will be a GP. It will be an infinite GP. So whenever you have an infinite GP, you can use the sum of, absolutely, you can go ahead and use the sum of infinite GP, which will be A upon 1 minus R. A is the first term, 1 minus R is the common ratio. When you go from one term to another, you are multiplying with 1 by 2 square. So this is going to be half 1 minus 1 by 4. 2 by 3 is the answer to this question, right? Just as a homework, give it a try. If instead of odd, it would have been even. And find the answer. Okay. Now, this is a good question. This is easy, but it is very differently worded. Give this a try. An experiment has 10 equally likely outcomes. A and B are two non-empty events. A has 4 outcomes. Then the number of outcomes B must have so that A and B are independent. When will A and B be independent? If A intersection B is A into B. Isn't it? Only if A intersection B is A into B, then A and B will be independent. Now, if I go ahead and if I take suppose number of events in B is X. So A and B will be independent if this is 4 into X. This is one thing that we are sure. A and B will be independent when A intersection B is 4 into X. Right? Now, it is asking what will be this X for A and B to be independent. Now, one thing that we know is that whatever this comes out to be, it must be an integer because this is a number. It has to be an integer. It cannot be a fraction because it is a number, right? Another thing which we know is that if I were to go ahead and I were to find this in terms of probabilities, right? Then this would have become probability of A intersection B is equal to probability of A into probability of B. And it says that the experiment has 10 equally likely outcomes. It means that here in terms of probabilities, it would have meant that 4 by 10 into x by 10, this would have been the probability of A intersection B. Now can you think what x can be? Anyone? I think I've given enough hint. Okay. Yes. Now it's very clear. I have already given the biggest hint. I want this to be an integer. Okay. Why? Can someone explain why would that be? That is correct. Yes. Exactly. We want it to be divisible. We want this to be an integer, right? And for this to be an integer, for me to be able to go ahead and for me to be able to check that there is an independence, I want that 4x, whatever this 4x is, this should also be divisible by 10. And when will this 4x be divisible by 10? Only if x is 5 or 10. Otherwise, it will not be divisible by 10. So it means that the only possibilities that I will be having will be x can be either 5 or 10. For any other value, it will not be divisible and we will not be able to get an integer, right? So the only possible answer to this one can be D. It's a very differently worded question, which you have to go ahead and understand. You can also go ahead and also try this as, you can also go ahead and also try this as, have as different options, hit and try. Mane, you can go ahead and do something like this also. That try with option number 1. That if it is option number A, then what will I get? I will get probability of A intersection B as 4 by 10 into 4 by 10, which will be 16 by 100, right? Now, if you look into 16 by 100, then you cannot have this as one of the answer, because this would mean that if I look at this 16 by 100, we don't have any common expression which can go ahead and give me probability of A intersection B. If I go ahead and if I look at this 5 or 10, you try different options. But if I look at 5 and 10, what will happen? Probability of A intersection B will go ahead and become probability of A into B. So probability of A will be 4 by 10. Probability of B will be 5 by 10. And this will give me 20 by 100. That means it will give me 2 by 10. Right? This makes sense. This tells me that I have to have 2 out of 10 outcomes. This is making sense. Here, you will not be able to go ahead and get a common expression. So for example, if I just go ahead and if I just solve this one, how would this go ahead and how would this look if I have to bring it in terms of 10? So I can say 16 can become, say, 10, and suppose I take, say, how do I explain this thing? If I go ahead and if I have to break 16 by 100, then this is not able to go ahead and it is not able to give me a common expression in this case. It's not able to go ahead and it's not able to fit the definition of A intersection B. It's not able to go ahead and come in the form of 1 into something. I want to have an integer placed there, right? This is able to go ahead and do this. I'm able to write this as 1 into 2 by 10. This is fulfilling that task, but this is not fulfilling a task. I'm not sure if this is making some sense to you. Is it? Should I repeat this again? Okay, let me just try to explain this again. So it is going ahead and it is saying an experiment has 10 equally likely outcomes. So that means that each of the options are equally likely. So therefore, when I find out probability of any outcome, very easy way I'll explain. If I want to find out probability of any outcome, it should be something divided by 10. Each of them is equally likely. Each of them has an equal chance of occurring, right? There are 10 outcomes. Each has an equal chance of occurring. So each can be said as probability 1 by 10. This makes sense? I am saying here, there are 10 outcomes. Each outcome has equal chance of occurrence. Therefore, each should have probability of 1 by 10. When I find in terms of probability, since they're equally likely outcome, they should have the probability attached to them should be 1 by 10. Now, event B, let the number of times that it occurs, the number of occurrence be x. Then the probability of B will be number of times it occurs. That means favorable number of events upon total number of events. A should also have this thing. Probability of A should also be favorable number of events upon total number of events. Now, we are saying probability A intersection B should be equal to probability of A into probability of B. This is what we are sure. If I now go ahead and if I look at just A has 4 outcomes, right? So since A has 4 outcomes, we can say probability of A will be 4 divided by 10, since A has 4 outcomes. Let us go ahead and let us now think about what has happened. Probability of A will be 4 by 10. Probability of B will depend on how many outcomes B has. Number of outcomes B has. So let the number of outcome B has is x. So its probability will become x by 10. And this will be probability of A intersection B. Right. Now, one thing that we can go ahead and we can understand, if you just think about it, usually, अगर मैं normally देखूं, independence छोड़ दूं, अगर मैं normally देखूं, तो मुझे पता है कि probability of A intersection B can be written as number of events in A intersection B upon the total events. ऐसे ही probability को define करते हैं, favorable events divided by total events. Total event we know is 10 only. Favorable events हमें ये नहीं पता ये कितने हैं A intersection B में, right? But we know something very sure, that when I talk about the number of events in A intersection B, तो ये जो number of events होंगे, they will be a number because these are number of events. So number of events in A intersection B, they cannot be a fraction. Let me now go ahead and rewrite this thing. I can write this as 4x by 10 into 1 by 10. 4x by 10 into 1 by 10. हमने क्या बोला? हमने बोला कि ये जो भी आएगा, because I've got 1 by 10 here. That means the number of events that I have, it will be this part. ये वाला part ही तो number of events बनेगा. और ये वाला part ये denominator बनेगा. So can I go ahead and can I write this as 4x by 10 upon 10? So it means that the number of events, if I compare numerator with numerator, it will be this. And this cannot be a fraction. ये fraction नहीं हो सकता है, because it is number. So the number of events that I have got, it will be 4x by 10. ये fraction नहीं हो सकता. This is my number of events. Now you put that x, इनमें से that x, such that this part, it turns out to be a number. It should not be fraction. So 4x by 10 has to be a number, and that is possible only if x is 5 or 10. That is what I was trying to show here also. right? So we want this to be satisfied. And this is possible only when x is 5 or 10. This is another way in which you can go ahead and think about it. I have found out the probability of A intersection B. This is coming as this. Probability of anything can be written as number of that events divided by the total. Total I know is 10. So number of events must be 4x by 10. Number cannot be in fraction. Number has to be a number. So therefore 4x by 10 has to be a number. For 4x by 10 to be a number, x can only take 5 or 10. Others it will come as decimal. And favorable number of events, and it cannot be a decimal. So therefore x will be either 5 or 10. That will be the answer to this question. Is it clear now? Okay, I hope it is clear. I am just, the basic thing is that we are finding the number of events, and number of events cannot be turning out to be a decimal. It cannot be a decimal. Okay. It's a little tricky question, but it's not difficult to think if you understand the gist behind it. Okay. This is the last question I want you to try for today. Just give this question a try. This is an excellent question because it is combining maths and stats together. What is IIT? Independently. We have done this in stats and identically distributed. First of all, this is a homogeneous set of equation, AX equal to 0. A homogeneous set of equation can only have two things, either infinite solution or unique solution. No solution homogeneous set of equation में नहीं होता है, या वो unique solution होता है. Unique solution अगर होगा तो that means all x's will be 0. That's a unique solution. Yeah, there will be infinite solutions that solve this. So therefore, we are sure that at least one solution will definitely exist because this is a homogeneous set of equation. So definitely, at least one solution will exist and its probability is 1. We are 100% sure that at least one solution will exist. This is also covered in my advanced video lectures where I have taken complete lecture on homogeneous set of equation. Right? So we are clear that at least one will exist. Now it says find the probability of having unique solution. Find the probability of having a unique solution. So when do you have a unique solution in any system of equations? A unique solution occurs when determinant is not equal to 0. Right? When determinant of something is not equal to 0. So what is the determinant of this? What is this? If I write it in the matrix format, what will this be? Alpha, beta, mu, v. Right? Alpha, beta, mu, v. And when will its determinant be not equal to 0? When alpha into v will not be equal to mu into beta. when alpha into V will not be equal to mu into beta, right? Now you need to go ahead and find this probability. Give me a probability number for this. Good. So when all can you go ahead and when all can you have ulta karke dekh lo. When all will you have determinant as 0? I don't know if my pen will work. It's charging, just went off. When all will the determinant be equal to 0? Determinant can be equal to 0 when the right hand side product and the left hand side product will match, right? So how many such cases can be there when the product will match? Just find out those cases. Take any two numbers and give it a try. Just give me a minute. Let me just arrange a new pen. So when will the product be equal to each other? When the product can be equal, supposedly, I tell you that alpha is 1, V is 3, mu is 1, and beta is 3. Let's take some examples. When all determinant will be equal to each other, equal to 0. Determinant will be equal to 0 when this product is equal. This product can be equal, case 1, when alpha is 1, V is 3, mu is 1, and beta is 3. Case 2, when alpha is 1, V is 3, mu is 3, beta is 1. Case 3, when alpha is 3, V is 1, mu is 3, beta is 1. Case 4, when alpha is 3, V is 1, mu is 1, beta is 3. Case 5, when alpha is root 3, V is root 3, mu is root 3, beta is mu 3. You need to see when all cases can be there, when the product will be equal. These two product will be equal to each other. You have to go ahead and consider all those cases. Right? You have to find out the probability in terms of probability. क्योंकि इन्होंने यहाँ पे ये भी बोल दिया ना, they are independent and identically distributed. So you have to find out the probability that alpha into V will be equal to probability of mu into beta. Isn't it? This is what we want to go ahead and we want to find first. And because these are independent, probability of alpha into probability of V equal to probability of mu into probability of beta. This is what we need to go ahead and what we need to find out. I've just taken one example, not necessarily 3 beta. I've just taken that suppose I want the product to be 3. Suppose. Just to show you that there are multiple cases that can be formulated. Right? So this is what you need to keep in mind. This is what my condition is. So now if you try and formulate it exactly. So when you go ahead and you do this, you will find out that you will be seeing that the product will be equal to each other in 5 cases. right? That is one way of thinking about it. You will be noticing that when we go ahead and when we find out that when all, can the system go ahead and can the system have a unique solution? Unique solution means that the product will not be equal to each other. It will be in 3 out of 8 cases. It will be ideally 6 out of 16. In 6 out of 16 cases, you will be noticing that you will be getting a unique solution, right? 3 out of 8 cases will come out. So yes, this would be a correct statement. The probability of equations having a unique solution will turn out to be 3 by 8. That is the correct answer. So answer to this question should be A. Both the statements are correct. Unique is non-trivial always. Unique is the trivial solution always, not non-trivial. Whenever you have a unique solution, the only solution possible in homogeneous set of equation is a trivial solution when all x's are 0. Otherwise, when you have infinite solution, only then you will have a non-trivial solution. The only unique solution is all x is equal to 0, a trivial solution. Zero, zero is the only unique solution. Yes. The only unique solution of homogeneous system of equation is 0, 0, which is a trivial solution. That is the correct statement. Okay. Let me explain in another way. This is just an example I had given you. Let me just take this again and let me just explain you what we are doing in this case. So it is saying that there is, take it like this. This would be even easier to understand. It says that there are 4 alpha, beta, mu, and v. These are independent and identically distributed random variable. Each of them takes the value 1 और 0. There are only 2 values जो हर एक ले सकता है. मतलब अल्फा भी 1 ले सकता है और 0 ले सकता है. ऐसे देख लो, बीटा भी 1 ले सकता है, 0 ले सकता है, म्यू भी 1 ले सकता है, 0 ले सकता है, और वी भी 1 ले सकता है, 0 ले सकता है. और हर वैल्यू लेने का प्रोबेबिलिटी इक्वल है. ठीक है. नाउ व्हाट डू वी वांट? We want to have a unique solution. हमें unique solution का probability निकालना है. Unique solution का probability मतलब हमें ये निकालना है कि जब हम इसको matrix form में लिखें और उसका determinant निकालें, that should be non-zero. When we write this in the matrix format, we get alpha, beta, mu, and v. So we want for a unique solution कि alpha into v minus mu into beta जो है वो non-zero है. This is what I want. अब ये non-zero, not equal to 0, when all it can go ahead and when all it can come non-zero, दो ही situation हो सकता है. Alpha into v 1 आ जाए और beta into mu 0 आ जाए. Then also it will be non-zero. या alpha into v 0 आ जाए और beta into mu 1 आ जाए, then also I will get this to be non-zero. These are the only 2 ways in which I can get non-zero. अगर ये भी 1 हुआ और ये भी 1 हुआ, I will get 0. And if this is also 0 and this is also 0, I will get 0. So the only possibilities for a unique solution, when I will get this to be unique, that means determinant non-zero, will be when 1 is 1 and other is 0, and yeah, ye 0 ho jaye, ye 1. Why I am saying 1 and 0 now? Because these can only take values 1 and 0. तो इनका जो प्रोडक्ट है वो या 0 हो सकता है या 1. Either the product can be 1 or 0. Right? So now what I want is कि अगर एक का प्रोडक्ट 1 आए तो दूसरे का 0 हो जाए, एक का 0 आए तो दूसरे का 1 हो जाए, so that when I find the determinant it is non-zero. Now you need to find the probability associated with them. So the probability that alpha into V will be 1 is nothing but probability alpha 1 into probability V1. Tabhi to product will be 1. And both alpha and V can take only two values. Alpha दो ही values ले सकता है, V भी दो ही values ले सकता है. So they can take each value with probability half. So this probability that alpha is 1 and V is 1 will be 1 by 2 into 1 by 2, which will be 1 by 4. Similarly, probability beta into mu will be 0. The product, when can beta into mu be 0? कब कब 0 हो सकता है? It can be 0 if beta is 1, mu is 0. It can be 0 when beta is 0, mu is 1. It can be 0 when both of them are 0. In all three cases, you will get the product to be 0. These are independent events. So I can just make a product out of them. Mu equal to 1 plus probability. So this will be half into half plus half into half plus half into half. And you will get this as 3 by 4. So what you have found out is, you will find out that probability alpha into V equal to 1, इसका probability 1 by 4 आएगा. Since these have same distribution, ये भी same आएगा. Probability beta into mu will also be 1 by 4. Probability alpha into V will be equal to 0 will be 3 by 4. And probability beta into mu equal to 0 will also be 3 by 4, like I found out. Now you just have to add these cases together. So what are the two cases? That the determinant will be non-zero if this happens together. Sorry, this happens together. That this is 1. This is 1 and this is 0. This happens together. Or this happens together, that this is 1 and this is 0. So determinant will be non-zero. Ka probability ho jayega 1 by 4 into 3 by 4 plus 3 by 4 into 1 by 4. 6 by 16. 3 by 8. This is a formal way of doing it. Okay. Try this question again. Sometimes in the 2-marker question, you will see difficult questions also. It is not all going to be merry. So you have to understand things well. हमने पहले देखा कि homogeneous system of equations में unique solution कब आता है? Unique solution तब आता है जब determinant non-zero होता है. Determinant को non-zero होने के लिए इस product को non-zero होना जरूरी है. Product non-zero तब होगा ये subtract करके जब दोनों values equal ना हो, वरना the answer will be 0. So it will be possible if this is 1 and this is 0, or if this is 0 and this is 1. Now we are just finding the probabilities when this can happen, right? And we are getting the answer. Just give it a try. If you still have doubt, post it in the group. I'll answer it. Okay, just one last. This is a homework question. This is not from stats, but I want you to give it a try. Please take a screenshot of this and try this and post the answer. Post it in the group, beta. I'll answer it. Take a screenshot of this, go ahead and answer this question, okay?